For 30 years, the fishermen of Aralsk kept their boats. They had no water to sail them in. The sea had vanished, retreated so far that the port stood 60 miles from the nearest shore. But they kept the boats, dry docked on cracked salt flats, painted and repainted, ropes coiled and waiting. If you had asked them why, most would not have been able to explain it. It was something older than reason. The sea had been there for thousands of years. Maybe it would come back. In 2005, an earthen dam, 87 meters tall, was completed along what used to be the northern boundary between two bodies of water. It cost $86 million. Within 18 months, the water level in the northern section had risen by 3 meters. Fish species that had not been recorded in those waters for decades appeared not stocked, not transplanted. They came back on their own. The fishermen of Aralsk had their sea again. I am Tom Marsh, and this is the story of the largest environmental disaster in recorded history and the smallest intervention that began to undo it. The Aral Sea sits in Central Asia, straddling what is now Kazakhstan and Uzbekistan. If you have never heard of it, here is what it was: the fourth largest lake on Earth. An inland sea larger than Ireland, fed by two great rivers, the Amu Darya from the south and the Sir Darya from the north, flowing down from the mountains of Tajikistan and Kyrgyzstan across the flat steppe. Millions of people lived around its shores. The fishing industry pulled 40 to 50,000 metric tons of fish per year, according to Soviet records from the 1950s. 24 species of fish, ports, processing plants, canning industry that exported across the Soviet Union, pelicans on the water, flamingos in the shallows, a working, living, enormous sea. And then someone decided to water cotton. This is the part of the story that is hard to sit with, because it was not an accident. The disappearance of the Aral Sea was not a drought, not a geological shift, not a slow natural recession over centuries. It was a plan. In 1918, Lenin described Central Asia as a land that could be turned into a great cotton producer. By the 1950s and 1960s, the Soviet government built one of the most ambitious irrigation networks in human history, pulling water from the Amu Darya and the Sir Darya into canals stretched across millions of hectares of desert. The goal was to make the Soviet Union self-sufficient in cotton and later rice and other crops. The goal was achieved. By the 1980s, the Soviet Union was one of the largest cotton exporters in the world. The engineers who built the canal system knew what would happen to the sea. There are internal Soviet documents from the 1950s acknowledging that diverting the rivers would destroy the lake. The decision was made anyway. The sea was deemed less valuable than the cotton fields. This was not negligence. It was a trade made deliberately at a scale that is difficult to comprehend. By 1960, the two rivers together were delivering roughly 60 cubic kilometers of water per year into the Aral Sea. By the mid-1980s, that flow had dropped to almost nothing. Some years, the Amu Darya did not reach the sea at all. It was drunk dry by the canals before it got there. The sea began to shrink. At first, slowly enough that people noticed only at the margins. Beaches that had been at the water's edge were suddenly a quarter-mile inland, then half a mile, then 2 miles. The fishing industry did not collapse all at once. It contracted year by year as the water receded and the salinity rose. Salt concentrations that had once been around 10 grams per liter climbed through the 1970s and 1980s. Native fish can tolerate modest increases, but by the 1980s, salinity in parts of the sea was approaching 100 grams per liter, roughly 3 times the salinity of the ocean. No freshwater fish survives that. By 1987, the commercial fishery was finished. The canneries closed. The ports found themselves landlocked. The boats stayed, rusting, yes, settling into the cracked salt pan, but staying. What happened to the exposed seabed is one of the more haunting ecological consequences of the 20th century. When the water left, it did not leave behind clean sand or bare earth. It left behind decades of agricultural runoff, pesticides, herbicides, fertilizer residue that had been draining into the sea from the cotton fields for 30 years. All of that settled into the sediment, and when the sediment dried and the wind came, which it always does across the flat Central Asian steppe, it picked up the salt and the chemicals and carried them. Dust storms that spread across 100,000 square kilometers. The World Health Organization documented elevated rates of respiratory illness, anemia, and kidney disease in the communities around the former shoreline. Children born in the Karakalpakstan region of Uzbekistan in the 1980s and 1990s showed health outcomes measurably worse than children born a decade earlier. The sea was gone and it was still killing people. By 2000, the Aral Sea had lost 80% of its water volume. By some measurements, it had split into separate remnant bodies, the northern small Aral, mostly in Kazakhstan, and the larger but far more degraded southern portions in Uzbekistan. What had been a single coherent sea was becoming an archipelago of shrinking puddles, each saltier than the last, each supporting less life than the one before. The southern portions are, as of this telling, effectively unrecoverable on any human timescale. The damage is too deep, the rivers that fed them too thoroughly diverted, the political and economic realities of the irrigation system too entrenched to simply undo. 40 million people depend on the agricultural water. You cannot ask them to thirst so that a sea can fill. But the north was different. The small Aral, the northern remnant, was still fed barely by the Syr Darya, and the Syr Darya had been partially rehabilitated during the 1990s, as Kazakhstan and the international community began to understand what had been lost. Flow was being restored. The question was whether the water arriving in the north would simply leak southward into the larger lower southern basin and dissipate without saving anything. The answer was the Kokoral Dam. Kokoral in Kazakh, the name means something close to blue land or green-blue island. There had been an island by that name in the Aral Sea. By the 1990s, it was no longer an island. It was a peninsula attached to the dry seabed. The dam was built across the Berg Strait, the narrow passage connecting the northern and southern sections of what remained of the sea. Construction on the permanent dam began in 2003, funded by the Kazakh government and a World Bank loan. It was completed in August 2005. The engineers had predicted that the water level in the small Aral would rise by 2 to 3 meters over roughly a decade if everything went as planned. It rose by 3 meters in 18 months. The sea filled faster than the models expected. By 2007, water surface area in the northern section had more than doubled compared to its lowest point in 2003. Salinity dropped from over 30 grams per liter in some areas to around 8 to 10, close to the original conditions. And here is where the story stops being about engineering and starts being about something harder to explain. No one stocked the northern Aral with fish. There was no formal restocking program in the initial phase. What happened was that the Syr Darya, as its flow was partially restored, carried fish back downstream. Species that had survived in the river, Aral bream, roach, perch, moved back into the expanding water. They had been waiting in the river the whole time, the same way the fishermen had kept their boats. The function was intact. The habitat just had to exist again. A study tracking the recovery of fish communities in the small Aral, conducted by researchers from Kazakhstan in collaboration with international partners and published in the years following the dam's completion, documented the return of commercially viable fish populations within a window that surprised even the project's own scientists. By 2006, local fishermen were reporting catches again. By the 2010s, the annual fish harvest from the northern Aral had climbed back into the thousands of metric tons, not the 50,000 of the 1950s, but real, measurable, economically significant recovery. The birds came back too. Satellite imagery and ground surveys documented the return of nesting populations of species that had abandoned the shoreline during the worst decades of shrinkage. The vegetation at the waterline, the reeds and sedge that provide the structural foundation for bird habitat in shallow inland waters, reestablished where the water stabilized, The ecosystem did not need to be rebuilt piece by piece. It needed water and time, and it reassembled itself. There is a phrase that ecologists sometimes use when talking about degraded systems that recover faster than expected: ecological memory. The idea is that the capacity for the ecosystem to function, the species relationships, the soil chemistry, the migratory patterns, the behavioral adaptations is not fully lost, even when the system collapses on the surface. It persists in the surviving fragments. In the seeds buried in the dry sediment, in the fish holding in the tributary rivers, in the birds still following the same migration routes, even when they arrived to find nothing but salt flat. The system was not dead. It was holding its breath. The Aral Dam breathed for it. None of this is simple, and I want to be honest about that. The southern Aral remains largely a catastrophe. The communities in Uzbekistan's Karakalpakstan region still live with the health and environmental legacy of the disaster. The irrigation system that caused the shrinkage still operates because it has to. The broader basin has not been fixed, and the word fixed may not even apply at the scale of the damage done to the southern sections. What has been saved is a piece, the northern piece, and that piece required a dam, international funding, and decades of political negotiation to hold together. This is not the story of nature quietly healing itself without any help. It is the story of what nature can do when you give it the minimum conditions it needs after you have spent half a century stripping those conditions away. But the minimum conditions here were remarkable in their simplicity. A wall of earth across a strait, and the decision to let the water accumulate rather than drain away. What returned in response was not planted, not engineered, not coaxed back with careful hands. The fish moved up the river when there was somewhere to go. The birds landed when there was water to land on. The reeds grew where the sediment was wet. The fishermen of Aralsk, the ones who had kept their boats on the dry lakebed for 30 years, launched them again. There are photographs from 2007 of men in small wooden boats on the small Aral pulling nets with water stretching behind them to the horizon. The sea is not large, it is not what it was, but it is there. There is something that stayed with me when I went deep into the records of this story. The name Aralsk, the port city on the northern shore, comes from an older word, the same root as Aral. In the Kazakh and Turkic languages, Aral means island. The sea was named for its islands. When the sea vanished, the ports became islands of a different kind, landlocked outposts in a salt desert, holding the memory of the water in their architecture, their boat docks, their canneries, their nets. And when the water came back, the name finally made sense again. The city of islands was surrounded by water once more. That is the kind of fact that should not move you as much as it does, but it does. Here's what I take from the Aral Sea. Beyond the engineering and the biology, we have a tendency when we look at an environmental disaster of that magnitude to declare it final, to update our maps, retire the name from the living world, and file it under things we lost. The Aral Sea was filed there. Scientists wrote papers about it using past tense. Textbooks described it as an example of irreversible human impact. And they were right about much of it. Large portions of it are irreversible. But in the northern basin, a remnant held on in the river, and in the instinct of the fish, and in the memory encoded in the sediment, and when the minimum was provided a dam, restored flow, time, the system came back farther and faster than the models said it should. We did not restore the Aral Sea. Not fully, not in the south. But in the north, we stopped taking from it. We gave it back some of what it had lost, and it did the rest. The fish knew how to be fish. The reeds knew how to grow. The birds knew the route. None of that had to be taught again. It was waiting. If you have thoughts on this, on whether more of these kinds of projects are worth the cost and the difficulty, on whether we owe the communities in the South the same level of effort that was given to the North, I want to hear them. Drop them in the comments below, because these are not simple questions, and I think the answers matter. If this story moved you at all, share it. Most people have heard that the Aral Sea disappeared. Very few have heard that part of it came back. That gap is worth closing. And if you want more stories like this, cases where the math looked hopeless and the ecosystem found a way, subscribe. There are more of these than you would believe, and I have many more to tell you. Not restoration by design, recovery by permission. I am Tom Marsh. Thank you for watching.